Hi, this is Bhupati from Department of Mechanical Engineering, Sri Shanmugha College of Engineering and Technology. So today's topic is refrigeration system. Refrigeration, it is defined as the process of providing and maintaining a temperature well below that of surrounding atmosphere. In other words, refrigeration means it's a cooling system. So terminologies of refrigeration. First one, refrigerating effect. It is defined as the quantity of heat extracted from a cold body or space to be cooled in a given time. N equal to heat extracted from the cold space by time taken. Specific heat of water and ice. It is the quantity of heat required to rise or lower the temperature of 1 kg of water or ice through 1 Kelvin or 1 degree Celsius in 1 second. So specific heat of water, that's a standard value 4.19 kilojoule per kg Kelvin, and the specific heat of ice is 2.1 kilojoule per kg Kelvin. So the specific heat means, for example, we'll take water that is initially at 27 degrees Celsius. You want to increase the temperature, for example 27 to 28, we have to add a heat. It absorbs some amount of heat to rise the temperature from 27 to 28. That amount of heat is called as a specific heat. Capacity of refrigeration unit. Capacity of refrigerating machine are expressed by their cooling capacity. The standard unit used for expressing the capacity of refrigerating machine is ton of refrigeration. 1 ton of refrigeration is defined as the quantity of heat abstracted to freeze 1 ton of water into 1 ton of ice in a duration of 24 hours at 0 degree Celsius. Heat extracted from at 0 degree Celsius equal to latent heat of ice. Latent heat of ice equal to 336 kilojoule per kg. So 336 kilojoule of heat should be extracted 1 kg of water at 0 degree Celsius to convert it into ice. Then coefficient of performance. The performance of refrigeration system is measured by the using the term coefficient of performance. It is defined as the ratio of heat extracted in a given time to the work input. So coefficient of performance equal to heat extracted in evaporator by work input. So coefficient of performance equal to refrigerating effect by work input in the formula N by W. COP value is always greater than 1 and known as theoretical coefficient of performance. Refrigerant. So refrigerant means any substance that absorbs heat through expansion and vaporization process and loses heat during condensation is in a refrigeration process is called refrigerant. Some example of refrigerants are air, ammonia, carbon dioxide, sulfur dioxide, freon, methyl chloride and methylene chloride. Refrigerant are classified as two types, primary refrigerant and secondary refrigerant. Primary refrigerant. It is a working medium which is used for cooling the substance by absorption of latent heat. The refrigerant are ammonia, carbon dioxide, sulfur dioxide, freon, etc. Secondary refrigerant. Secondary refrigerant is the substance already cooled by primary refrigerant and then employed for cooling purposes. Ice, solid carbon dioxide. This refrigerant cool the substance by absorption of their sensible heat. Types of refrigerator. Ice refrigerator. Ice is kept in the cabinet of refrigerator and this acts as the refrigerating means. Air refrigerator. Air is used as a working agent in this type of refrigerator. Example, Bell-Coleman cycle. Vapor refrigerator. The working agent employed in this type of refrigerators are ammonia, carbon dioxide, sulfur dioxide, freon, etc. Application of refrigeration. So normally refrigeration used in various industries. In chemical industries for separating and liquefying the gases. In manufacturing and storage, ice. For the preservation of perishable food items in cold storage. For cooling water. For controlling humidity of air manufacture and heat treatment of steels. For chilling the oil to remove wax in oil refineries. for the preservation of tablets and medicines in pharmaceutical industries, for the preservation of blood tissues, etc. For comfort air conditioning, the hospitals, theaters, etc. So these are some application of refrigeration. Next we move on to working of refrigeration system. There are two types of refrigeration system: vapor compression refrigeration system, vapor absorption refrigeration system. The main components of the refrigeration systems are compressor, condenser, expansion valve. Expansion valve is called it as a capillary tube, and evaporator. So these are the four main components of the vapor compression refrigeration system. We'll see one by one. Then this system consists of compressor, condenser, a receiver tank, an expansion valve, and an evaporator. Compressor. Reciprocating compressor generally used for very big plants. Centrifugal compressors directly coupled with high-speed rotating engines are used. Then compressor for very big plants, normally it's used the centrifugal compressors directly coupled with high-speed rotating engines are used. So two types of refrigerant, the compressor, reciprocating compressor and centrifugal compressor. These two types will be used based on the size of the refrigeration system. Condenser, it is a coil of tubes made of copper. Then receiver tank, it is the reservoir of liquid refrigerant. Expansion valve, this is the throttle valve. High pressure refrigerant is made to flow at a controlled rate through this valve. Evaporator, this is the actual cooler and kept in the space to be cooled. The evaporator is a coil of tubes made up of copper. So the working of vapor compression refrigeration system, the low pressure refrigerant vapor coming out of the evaporator flows into the compressor. The compressor is driven by a prime mover. The compressor, the refrigerant vapor is compressed. The high pressure refrigerant vapor from the compressor is then passed through the condenser. The refrigerant gives out the heat it had taken in the evaporator, the heat equivalent of work done on it on the compressor. This heat is carried by condenser medium, which may be air or water. The high pressure liquid refrigerant then enter into the expansion valve. This valve allows the high pressure liquid refrigerant to flow at a controlled rate in the evaporator. While passing through this valve, the liquid partially evaporates. Most of the refrigerant is vaporized only in the evaporator at a low pressure. The evaporator, the liquid refrigerant absorbs its latent heat of vaporization from the material which is to be cooled. Thus the refrigeration effect is obtained. Then the low pressure refrigerant enters the compressor and then cycle is repeated for working of refrigeration system. Application of refrigeration system: preservation of food items like vegetables, milks and eggs, preservation of medicines, preservation of blood tissues, etc., preservation and cooling of cool drinks, preservation of chemicals, cooling of water, industrial and comfort air conditioning, process of dairy product. So this is the skeleton of the domestic refrigerator. See here, this is the uh, refrigerator. Here this is the capillary tube. This is the evaporator tubes will be located here. The compressor, the drum will be located at the back side of the fridge. Thank you.